Hello everyone. Today we'll begin our study of trigonometry. As groundwork, we will be studying angles, and to start out, we'll talk about some of the vocabulary involving angles that I find important. So, first off, we have the standard position of an angle. Now, for an angle to be in standard position, we need to put its vertex at 0, 0. 0, 0. I'm going to change the thickness of that line there. So a vertex here at 0, 0. To be in standard position, its initial side needs to be on the positive x-axis. So let's make sure that initial side of our angle is on the positive x-axis. So let's write on positive x-axis. Then the terminal side. Terminal side is the second side of the angle. In a sense, it's where the angle ends. So let's say that this angle ends in quadrant 2. Then we would be going out here. So the angle starts here at this ray and ends at this ray, which means in a sense that it is rotating counterclockwise. So to signal that the rotation is in the counterclockwise direction, I'm going to draw a little arc. Let me put this arc in a different color. Do a little arc from here over to the terminal side. So let's go back to blue. So the terminal side is, in a sense, the ending side. Alright, so positive angles versus negative angles. A positive angle is an angle that opens in the counterclockwise direction. And the angle that we just drew up on that axis is a positive angle because it opens counterclockwise, as we can see from that green arrow. A negative angle is one which opens clockwise. So that would be an angle that looks something like this. We've got an axis, angle in standard position. Now that angle is still going to have its initial side on the positive x-axis, but it's going to rotate the other way. It's going to rotate counterclockwise, and so it would open in this direction here. It might end in the same place as that previous example, but the way that it turns is different, and so it's a negative angle. Alright, next up. In terms of degree measurement, 1 degree is the same as 1/360th of a revolution, of a rotation in a circular fashion. And so, this angle that we've got up here in the upper right, it's a little more than a quarter of a rotation, and so a quarter of a rotation would be 90 degrees. And so it's probably going to be something like about 130 degrees or thereabout. Now, 1 degree is 1/360th of a circular rotation, but we can also talk about fractions of degrees. When we talk about fractions of degrees, sometimes you'll see it in decimal form. For instance, 1.5 degrees might be represented as 1.5 degrees. But there's also a different way to represent fractions of degrees. So the notation that we use for fractions of degrees looks like this. This means 1 minute. And 1 minute is 1/60th of a degree. Moving back a little bit, 1 degree is 1/360th of a circular rotation. And you can also divide each of these minutes, which is just a tiny, tiny fraction of a rotation, into seconds. And 1 second is 1/60th of a minute. So of course this is getting down into very tiny terms. We'll be using this notation later on. Alright, next up. Greek letters that we're going to see a lot here. Now, we've already used pi a lot in mathematics, but in order to represent angles, we often use Greek letters. One of them is the Greek letter theta. Another two that we use decently frequently are the Greek letters alpha and beta. On occasion, we may see sort of loopy looking letter like that, and that is the Greek letter gamma. And sometimes we'll also see the Greek letter phi. And that's, of course, in addition to the Greek letter pi that we've already used, although pi is usually not used to represent angles, but these Greek letters are. Alright, next up, some basic angles. Here you see a chart that shows 16 angles on it, and those 16 angles are 16 major angles. These angles are the multiples of 30 and 45, starting at 0 degrees and then basically going up to 360, but not including 360. So these, sometimes I'll refer to them in class as the 16 major angles. So these are multiples of 30 and 45. These are angles which are often represented in radian measure, and radian measure is something we're going to talk about next. And so these are angles which in degrees are worth memorizing, along with their locations on this handy circle. All right. So radian measure. Radian measure is a second way of representing the size, in a sense, of an angle. So degrees is the first way. Degree is 1/360th of a turn. Radian measure is often used in trigonometry to represent angles. The way that it's calculated is, for any particular angle, you take the arc length that's swept out by that angle when it's in standard position, arc length, and then divide it by the radius of the circle. We're going to get into more specifics with radians in a little while. So let's go on to the next page in your notes. This diagram here is basically the same thing as this diagram here, but instead of having our angle measurements in degrees, we have them in radians. Alright, so the way that one of the ways we can think about radian measurements is this way. Let's suppose that this was what's called a unit circle. Both of these, this one here and this one down here. Now, if this were a unit circle, it's a circle that has a radius of 1. So the distance from the center out to the edge is 1 unit. Well, that would mean that the diameter is 2 units. And so, if the radian measurement of an angle is the arc length divided by r, then we could think of this as we could think of it this way. Think of a whole spin around the circle, that angle. So it would have a terminal side, positive x-axis, and then it would open, go counterclockwise all the way around. And then we'd think, what would that arc length be? Because remember, the radian measurement would be arc length divided by the radius. Well, then the arc length would be the whole circumference of that circle. The circumference of the circle is measured by pi times the diameter. So then the diameter is 2 units, like we said just a moment ago. And so that arc length would be 2 times pi. The radius of this circle is 1 unit, as we also mentioned earlier. So the radian measurement for this angle, for this full spin around a circle, is 2 pi. And that's what we see right here. It's basically saying that 360 degrees is 2 pi. So any fraction of that 2 pi turn will be a certain fraction of 2 pi. For instance, half of a turn will be half of 2 pi. Half of 2 pi is pi, which we see here. And so on for all of these fractions of a turn going around the circle. Now there's of course a quicker way to figure out an angle's measurement in radians than doing it as a fraction of 2 pi. You can do it essentially like this. To convert from degrees to radians, we take our angle and multiply it by pi over 180. So for instance, this 90-degree angle here, what's that going to be in radians? We take 90 degrees and multiply by pi over 180. Take that, make it into a fraction. Both these have a factor of 90. That becomes a 2, that becomes a 1. Multiply across, and we have pi over 2, which is shown right here. The way to go, in a sense, backwards from radians to degrees is to multiply by 180 degrees over pi. So for instance, let's say that we're looking at this angle right here, this 5 pi over 4. We want to know what is that angle in degrees. So multiply that by 180 over pi. Pi's cancel. Now 180 and 4 both have a factor of 4 in it. Becomes a 45. Then we multiply straight across. 1 times 1 down in the bottom. 5 times 45 is 225. And so that is 225 degrees right there. Now when you're doing these conversions, it's really useful to know what the factors of 180 are. As you can see, sometimes you'll be simplifying with the number 180 in either of these formulas, so it's useful to remember what those factor pairs are. So 180 is 2 times 90, 3 times 60, 4 times 45, 5 times 36, 6 times 30, 9 times 20, 10 times 18, and 12 times 15. Remembering those factor pairs is pretty helpful when you're converting from degrees to radians. Next is the topic of coterminal angles. So coterminal angles are angles which have a terminal side located in the same place. So for this example, let's suppose that this outer arrow right here, this little angle, had a measurement of, say, 30 degrees. You could have another angle which starts in the same location and then goes past 30 degrees and then ends up in the same spot. So in a sense, this would be, let me do this one in green, it's going to be at least 30 degrees and then another full spin around. Well, the full spin around is 360. 30 plus 360 is 390 degrees. So 30 and 390 are what are called coterminal angles because they are angles with the same terminal side. Angles with the same terminal side. Since we're almost at the 15-minute mark, I'm going to pause here and pick up in video number 2.